Hey, good afternoon, everybody. Welcome to another webinar from UE Systems. I feel like it's been a second since we've done one of these. We were really going strong there at the beginning and took a little break as we were putting together our virtual conference that we did in July on the Leading Reliability Conference. So hopefully a lot of you got to check that out. It was a pretty cool experience to do that. But we thought we better get back on the horse and start doing our monthly webinars again, and probably do even some more as we get into September. But today we are going to be talking about leak detection. So we've got Adrian Messer, who most of you have probably heard present before, talking about planning and performing an effective ultrasonic compressed air leak survey. So pretty cool topic, certainly as far as ultrasound goes. That is kind of where we got our bread and butter and how we kind of got things started with ultrasound. And of course, you know, things have progressed, but it's still an awesome application and certainly a good starter application. So for those of you that are maybe new to ultrasound, great place to start. So you'll learn more about that here as Adrian presents. But just a couple things before I turn it over to him. You know, just always like to remind about our personal trainer program that we have. You know, we've got our great group of trainers who normally would be on the road practically, you know, every week out of the month, but most of them are of course kind of grounded at the moment as we're not able to travel and doing things mostly virtual. So they are ready and willing to hop on a GoToMeeting with you if you want to get some software help, if you have questions about applications, any kind of equipment questions that you might be able to get answered over a GoToMeeting. And so we're very happy to set those up and get you guys spun up on the software or reporting, anything you're learning about today, whatever the case may be. So just keep that in mind and help us stay busy and stay connected with you guys, even though we're not able to necessarily do that in person, though I think we're starting to see a little bit of that opening up. So it's been cool for some of the guys to be able to go get back out there and be face to face with you all. But anyway, just a reminder about that. Then our typical housekeeping. So we are recording this, and I will pop it up on our YouTube channel later today, so that you can check it out if you want to, if you have to hop off early, or if you've got a coworker that couldn't make it, then they can check that out there. And of course, all of our other webinars are also archived on there as well. So if you haven't checked out our YouTube channel, just go to YouTube and search UE Systems. Just a ton of information there. We've got everything kind of broken up into playlists, so you can pretty easily navigate to the webinars or tutorial videos, things like that we've got. Definitely welcome questions. You can type those into the little questions box. I'll be keeping an eye on those, can answer them, you know, as we go through the session. And of course, we'll toss them to Adrian at the end when we have some time for a little Q&A. So definitely don't be shy. It's a nice way to kind of interact as best we can as we're all doing this remote. So with that, I am going to turn the screen over to Adrian, and Adrian will let you take it away.
All right, awesome. Thank you, Maureen. Can you see that okay?
I can.
Okay, great. Well, again, just to reiterate what Maureen said, we appreciate every one of you being on today. Appreciate you taking time out of your day to be with us to hear about probably the most widely used application for ultrasound, and that's compressed air leak detection. So we're going to kind of talk about, you know, how to plan and perform an effective ultrasonic compressed air leak survey. But, you know, before we start, I was, you know, thinking about, you know, putting together the material for the presentation today. And I thought, you know, I'm going to start out with 5 things that an ultrasound technician can do in times of COVID. You know, I've seen lots of people coming out with lists of what to do during this time. And I thought, well, you know, why not include an ultrasound technician in that as well? So starting out with number 1, you know, focus on energy. You know, in these crazy times that we've been in over the last few months, now's as good a time as any to focus on some energy initiatives in your plant or facility. And when you think about it, an energy efficient plant becomes a competitive advantage. If you can make a product more efficiently and more reliably than your competitor, that becomes a competitive advantage. And I would dare to say the majority of you on the call today probably already have an ultrasonic instrument. So why not make use of that instrument during this time to go out and look for sources of energy waste in your plant or facility? One of those being what we're going to talk about today with compressed air leak detection. Number two, organize an energy treasure hunt. So what I'm talking about here is similar to like a Kaizen event where you form a team. The team goes out to a line or a machine, and they look for ways that they can improve the efficiency of that machine. This team would focus on looking for sources of energy waste in a facility. So that's the sole focus. I've actually been invited to participate in a few of these energy treasure hunts over the years. And the one thing that I've noticed is it helps having someone from outside the organization to participate because it just brings a fresh set of eyes. If you've been working in a plant or a facility for any length of time, you just kind of become accustomed to the way things are, and you kind of unfortunately go in with blinders every day, and you just kind of get used to the way things are. But having somebody come in from the outside, to help you in this treasure hunt, just helps to bring a fresh set of eyes, and helps to bring to light some of the waste and inefficiencies that may be occurring in the plant or the facility. So then what would happen is after this treasure hunt, the team would then compile and then document everything that was found during the treasure hunt. And ideally, that information would then be shared across the organization. So that way, similar facilities, sister companies can leverage that and make use of that information as well, and hopefully be able to organize their own. So again, it's just a great way to share those findings. 3 would be to start a portfolio of your PDM finds. So if you've ever heard me speak before, I'm always talking about how important it is for maintenance and reliability professionals to have good reporting and documentation of their PDM work. Not only is it a way to showcase the importance of maintenance and reliability, but it can also help to create awareness that maintenance and reliability is contributing value to the organization. It's not just a cost center, because unfortunately, nobody notices maintenance until something fails or something happens. But if you've got a portfolio or a compilation of your work, your findings, then, again, it helps to create awareness, but it's also a way to help, CYA, if you will. So if something does fail, you've got documented that it was found. And in a lot of cases, where maintenance says, hey, we found this problem 6 months ago, but you chose not to do anything about it. So again, it's just a way to have a documentation of your work. And if for no other reason, you can just be, have selfish reasons, and when it comes time for that annual evaluation, you've got a documentation of the work that you've done over that past year. 4 would be to update and clean up your ultrasound routes and databases. I know some of you out there have been, running mechanical routes with ultrasound for many years. And, you may just have some data that is really not useful to you anymore. So you can clean that database up. And if you're using DMS5, what we would recommend there would be to export that data out to Excel. So that way it's not permanently deleted, but you still have a record of all those previous readings. So, just as an example, so if you've been trending the decibel level, if you've got historical readings on an asset and there's been no alarm levels reached, everything still looks good, there's no reason to still have that data sitting in your existing route. So why not clean that up so that way you don't have to look at it or scroll through it. So again, in DMS5, you can just simply export that data out to Excel, just so you still have a record of it. And then you can just create another group just by simply copying from the group. So that way you don't have to rebuild the entire route. If you're using the latest version of DMS6, there's a feature in DMS6 that's called Group Cleanup that allows you to hide the old data. After you hide it, it will give you the option to permanently delete it if you want to, but you can just simply hide that out of your tree, so that way, again, it's not showing and you're not having to look at data that's not really valuable to you. But again, that's called the group cleanup in DMS6. Now, regardless if you're using DMS5 or DMS6, if you're unsure how to do that, or if you'd like for us to assist you with that, we can certainly help you with that. We can get online with you and we can help walk you through that process. So just reach out to us and we can help you with that. And then the final thing, again, it's something that we all kind of lose sight of the importance of, and that's doing sensitivity validations on your ultraprobes. If you've ever been through any of our level 1 courses, you know that we emphasize the sensitivity validation test, but it's just a test or a way to check to make sure that our ultraprobe is still within calibration, to make sure that we're getting consistent and accurate readings. So if you are looking to kind of restart your ultrasound program, or if you're looking to maybe you're in a situation where the ultraprobe is being used every day, that's, again, all the more important reason to make sure that we do the sensitivity validation test. Now, if you're ever in doubt, then if your instrument, if you feel like it needs to be in for like recalibration or just for service, again, if you're looking to restart your program, or if you're using it so much to where you feel like it probably needs to come in for recalibration, again, just contact us, and we'll get you a return authorization number before you send it in. We can get that serviced and back to you. If you're unsure if your instrument has ever been recalibrated, if you'll look underneath the bottom of it, when it comes in for service or recalibration, we would put a sticker on the bottom of it. So that'll give you the date of when it was last in for service. So look for that. But if you have any questions about how to do the sensitivity validation test on your specific model of instrument, again, reach out to us and we can give you the instructions on how to do that. So those are the 5 things that, 5 easy things, I would say, that an ultrasound technician can do during these times that we're in. So just an introduction to UE Systems. If you're on the call and you're not familiar with who we are, we have been around for almost 50 years, 1973. We do have a global presence as far as the development, manufacture, and support of handheld, airborne, and structure-borne ultrasound instruments, software, sensors, and training. And that's one of the things we really pride ourselves in, is the fact that we offer support. So again, if you have our equipment, if you're unsure that it's being used correctly, if you need some more specific type assistance, please reach out to us, and we can either come in on site, or we've been doing quite a bit of virtual online support type help. That could be with software, instruments, specific applications. Reach out to us. That's what we're here for. Training. Now we have been, we've had a very positive response from our online level 1 ultrasound course that we released earlier this year. As soon as we post those up, they tend to fill up rather quickly. And then more specific to compressed air leak detection, we do have an online compressed air leak inspector course. That's something that you can take at your leisure. So once you start it, you have up to a year to finish it. Most people will complete that course over the course of about a week. So it's about 5 to 6 modules. So it'll give you very specific training on how to use ultrasound for compressed air leak detection. So what equipment is available? We make a total of 8 different models of the UltraProbe instruments, along with some permanently mounted sensors. The 4 that I'm showing here, I would say, are the most popular ones that are used for compressed air leak detection. So starting over to the left, we have the UltraProbe 100. The easiest instrument we have to use by far. It's very economical, very operator friendly. So you could put this in the hands of anybody, and they're going to be able to use it to go out and troubleshoot, find leaks. You'll notice it also comes with a stethoscope module that you can do some basic mechanical type troubleshooting with, but that's the UltraProbe 100. Then move over to the right to the UltraProbe 3000. Now, this model here, we specifically came out with several years ago for energy applications, so compressed air leak detection and steam trap inspection. Similar in size to the UltraProbe 100, but unlike the 100, which is an analog instrument, the 3000 will provide you a true decibel level number on the display. So we'll see how that true decibel level number is important when we get to how we quantify and calculate how much a compressed air leak is costing. So you'll need an instrument that will give you a digital readout for that. And then moving over to the right again, the UltraProbe 9000. This is the first model that has frequency tuning. So again, it's still a digital instrument, still will give you a true decibel level number, but this model has frequency tuning, and that may be important to you if you want to get into using it for other applications. So where the first two, the 100 and the 3000, are really what I would consider to be entry-level troubleshooting type instruments, the 9 would be better suited for multiple applications like, bearings or steam traps, because we have the ability to adjust or change the frequency according to what the application is. And then the last model is the UltraProbe 15000. It may be a little overkill for compressed air leak detection, but we do see a lot of people using it for that, simply because it comes with your standard airborne scanning module as well as a long-range module. So that long-range module has a distance away from where we can be from, they say, the source of the sound, or the leak in this case, of up to about 90 feet away. So it's very well suited for facilities where you have overhead compressed air lines. We can just simply walk along the floor, follow that line using that long-range module, and we're able to pinpoint leaks just by standing on the floor. Another reason people like it, it does have a built-in digital camera. So you see in this picture, we're actually taking a photo of the leak location, so we can document that. And then when we download that information into the UltraTrend DMS software, we can use that photo to generate reports. We see a lot of people using those photos. They'll send those right over to, say, the planner scheduler. The planner gets the photo. They can kind of see what items may be needed to make those repairs, and then they can attach that photo to the work order itself. If you look at these 4 models, though, you pair them, well, at least the 3, the 9, and the 15, you pair those with our leak survey app that we're going to talk about. That's a free app that's available for download in the App Store or Google Play. So you take your UltraProbe, you take that leak survey app, and it becomes a very easy and affordable way to do a compressed air leak survey in your facility. Other than maybe some leak tags, those are the only 2 things that you would need to go out and perform a compressed air leak survey in your planner facility. So a little bit on the technology, what it is and how it works. So it, similar to the way an infrared camera sees what you can't see, an accelerometer feels what you can't feel, ultrasound instruments listen for sound that we can't hear. So there's things taking place within a typical planner facility that we can't hear just simply because all the other plant, noise, background noise. But with ultrasound, we're able to hear these sounds above all that ambient or plant background noise. And if we think about how ultrasound relates to normal human hearing, on the average, humans hear, kind of the upper threshold of what we're capable of hearing is around 16 to 17 kilohertz. Well, the ultrasonic range begins at 20 kilohertz. So the lowest frequency that we're able to tune or set the instrument to is still above the range of what we're able to hear as humans. So it's very important because, again, we're listening for sound that we can't hear. So we're able to hear these sounds above all the other plant and background noise. Since we're only listening for high-frequency sound, it makes it very easy to isolate and pinpoint the source, even from extended distances away. So it's very easy to do. We can filter out these sounds to avoid false readings. There's an adjustment on the instrument called a sensitivity. So, if you go through any of our level 1 courses, we spend a whole day on just the science and theory of how ultrasound works. And understanding the physics of sound and how sound waves travel, will help you to make better use of your ultrasound tool. One of the things that we always, kind of stress and teach is the fact that high frequency sound has a tendency to bounce and reflect off of solid surfaces. So if we're pointing the instrument at the floor, for instance, and we're hearing the sound of an air leak, we know that can't be correct because there's no compressed air lines on the floor. So we lower that sensitivity, and that is a way to, again, narrow down the field of view to help to block out and filter out those types of sounds to where we can avoid getting false readings with our instrument. And these are the core applications that we focus on at UE Systems. Again, ultrasound is all that we do. So and these are the core applications where we found that ultrasound is very effective and can be used for these types of inspections. So we're talking about leak detection today. So we're primarily just going to be talking about compressed air leak detection. You can also have leak detection, which would be a contact method. That would be steam trap inspections, to where we're listening to make sure that steam trap is operating the way that it should. With valves, we're listening for valves that may be in a leak by condition, or we're listening to see what that valve is doing. Is it open? Is it closed? Or is it leaking by? Another airborne application, so kind of leading into talking about the versatility of ultrasound is, any of those four instruments that I showed previously can be used for all these applications. So we're not just limited to leak detection, but the same attachment that we would use for airborne leak detection would be the same attachment that we would use for airborne electrical inspection. So you see in the photo here, we're scanning this MCC or the switchgear here, and we're listening for faults like corona, tracking, and arcing. So again, it's an airborne application where we're going to hear those faults, and we're going to be able to hear those sounds through any of these openings. So we're just simply scanning the seal around the door here. You've got some louvers, vent openings. And if we have those types of faults, that sound will exit out wherever there's an opening. So we're forewarned about any potential problems before we have to open up this equipment to do any kind of visual or, say, an infrared scan. And then equipment reliability and condition monitoring. That's going to be bearings, rotating equipment, and then ultrasound-assisted bearing lubrication, where we can listen to the bearing while we're applying grease to make sure that we're not over lubricating, or to make sure that we're applying enough grease to that bearing. And then there are different sources of high-frequency sound, and these are all things that we can detect with our instruments. So you have turbulence. So that's going to be our compressed air leaks to atmosphere, where we have something under high pressure that's trying to exit out through a crack or an orifice to low pressure or atmosphere, and that creates turbulence. You can also have internal turbulence, like we talked about with a steam trap. So when that steam trap cycles open and releases condensate, it produces turbulence. But then when that steam trap shuts back, the sound goes away. Ionization. So primarily we're talking about corona discharge. The definition of corona discharge is actually the ionization of air surrounding an electrical connection above 1,000 volts. The thing about corona, and where we see complementary use of ultrasound and infrared together, is the thing with corona is it typically will not produce enough heat to be detectable with a standard infrared camera, but it does produce high frequency sound. So if you're using a combination of ultrasound and infrared together, you're pretty well guaranteed to find just about any kind of fault that may be occurring with your electrical assets. Friction, so that's going to be with bearings in need of lubrication. So when you have a bearing that needs lubrication, there's going to be an increase in friction, therefore an increase in noise. So if we're listening to that bearing while we're applying grease, and if we're watching the decibel level, we want to see the decibel level falling as we apply grease. So as grease enters the bearing housing, there's less friction, therefore less noise. On the other hand, if we start to apply too much grease, then we'll start to see the decibel level going up. So if we're ever applying grease to a bearing and the decibel level starts to increase, we need to stop because we've reached the threshold where we've started to over lubricate or apply more grease than what's needed. And then impacting, primarily with slow speed bearings. So when you have a fault that starts to occur in these slow speed applications, and primarily we're talking about anything below 100 RPM, that fault will produce a subtle noise such as a click or a pop or a tick or a screech, and we're going to hear that in the headset. And then if you're using an UltraProbe 10,000 or 15,000, you can record the sound of that bearing, and when you play that sound file back in the UE Spectralizer software, those anomalies show up really nicely in your time waveform view, but those are impacting related faults. Now, some ultrasound instruments are on a fixed frequency. So like the UltraProbe 100 and the 3000, again, I referred to those as kind of entry-level type instruments. Those are on a fixed frequency setting. And typically, any of your instruments that are on fixed frequency settings are going to be around 38 kilohertz. And then some have frequency tuning. So again, like starting with the 9000, how I mentioned that is the first instrument that we have that has frequency tuning capability, in that we can tune or set the frequency according to what the application is. And then here are those recommended frequency settings. And just for reference, these come from an ISO standard for recommended use and guidelines for ultrasound, and it's ISO 29821. So in that ISO standard, it gives you what the frequency settings are. So you can see here we've got 40 kilohertz. That's going to be the one you'll want to remember for today's topic, and that's going to be the frequency setting for airborne leak detection, as well as airborne electrical. So basically any airborne application, you'll want to make sure that you have your UltraProbe set to 40 kilohertz. 30 kilohertz is what's recommended for bearings and mechanical, 25 kilohertz for steam traps and valves. And then if you're on those slower speed applications, again, anything less than 100 RPM or so, you want to be around 20 to 25 kilohertz. And it'd be a case to where you would just maybe start at 20 kilohertz and then tune up to about 25, or until you get the most clear sound in your headset, or, if you get a good steady decibel level reading. But those are your recommended frequency settings if you have an instrument that has frequency tuning. All right, so transitioning over to speaking specifically about compressed air leak detection. If you think about, ways that we can optimize our compressed air system, a lot of people are kind of quick to make massive capital investments in improving the efficiency of the compressed air system. But I tell you, a great place to start is just by simply going out and locating and then repairing compressed air leaks. The Department of Energy says that optimization of compressed air systems can provide efficiency improvements of 20 to 50%. And again, one easy way to do that is through going out and then not only finding, but also repairing compressed air leaks. You got to repair the leaks in order to realize these savings. All right, so another number that you can hear industry experts tell you, and I've heard this from many of the compressor companies out there, as much as 30% of the compressed air generated is lost due to leaks. So we can know at a minimum we can gain back or realize as much as 30% of the compressed air, we can get that back just by simply locating and then repairing those compressed air leaks. Now, if you look at what it takes to produce it, to what you get out of it, it takes about 7 to 8 horsepower of electrical power to produce 1 horsepower of compressed air power. And then just as an example, if we look at a 1/8 of an inch compressed air leak at 100 PSI at a cost per kilowatt hour of 22 cents a kilowatt hour, that air leak has almost a $3,000 per year leak. All right, so where should we begin? Really a successful compressed air leak survey begins partly with creating awareness of just how costly a compressed air leak is. You see a lot of misuses in compressed air in some of the plants that I visit, and it, not by intention, I guess, but it's just the way things are. So, we want to create awareness of exactly the fact that compressed air is not free and it is very expensive. And then we want to make sure that we select the right ultrasound instrument. Again, what kind of data do we want to get out of it? Who's the primary user going to be? And maybe we want to start out with compressed air leak detection now, but in the future, we want to grow the ultrasound program. So selecting an instrument that would be suitable for any kind of future use would also be something to take into consideration. Again, through these teams that can go out, such as an energy treasure hunt, we can identify areas where we have excessive misuse of compressed air, and we can potentially look for other methods to do the same task, but without using compressed air. Again, we think about making massive improvements to the overall compressed air system. Once you've gone out and located and repaired leaks, then we can think about doing some of those types of capital investments. We would want to create goals for the survey that align with the goals of the organization. I know many of you work in plants and facilities where, energy conservation, sustainability, all that is a big deal now, and rightly so. We want to make good use of the resources that we've been given. So we want to create goals for the air survey that also align with those same goals of the organization. And then, again, an important thing to note here is we want to make sure that we execute this with a very planned and organized approach, which we're going to talk about. Other goals of the survey, obviously, we want to reduce energy usage, which we can easily document with that leak survey app, because not only will we see the dollars wasted from those compressed air leaks, we'll also get a report of the CFM loss, and then we'll also give a report of the carbon footprint, so the wasted energy for how much of a carbon footprint these air leaks are costing us. We want to increase efficiency. When demand starts to creep up to whatever the maximum capacity is on the system, a lot of times, a lot of talk is given to having to rent compressors, bring in other compressors or install additional compressors. But again, a lot of times those types of investments can be nixed through just by simply locating and repairing compressed air leaks. That also helps us to maximize the most productive use of the air. We talked about greenhouse gas emissions, so we have ways that we can track that. Once we repair those leaks, we can see how much we've reduced our carbon footprint by. In some cases, there may be some safety related to air leaks, especially if you have some of the higher pressure systems where you're doing, specialty types of applications. We really haven't talked about specialty gases, but we're basically talking about any kind of pressurized gas, whether that be compressed air, whether that be hydrogen, helium, oxygen, argon, any kind of pressurized gas, we can use ultrasound to check for leaks. In some cases, there may be quality. So product quality may be of concern if you have excessive leaks on your system. And then improving reliability. We talked earlier about, an energy efficient plant. Well, it's very likely if you have an energy efficient plant, it's very likely that you're also going to have a very reliable plant. So these are all goals. These are all things that can come about through an effective compressed air leak survey. Now, prior to the survey, we want to review our compressed air applications. We want to review blueprints of piping, so that way we know where all of our piping is running. If you're in a plant or a facility that has some age to it, if it's been around for a long time, things have been added to, things have been taken away. So we need to know where the current use of compressed air, piping, where our current system is running. So we want to document that. We want to prioritize equipment location. So we talk about breaking it up into zones, breaking it up into areas. A lot of times we kind of default to asset criticality, might be a good place to start. Again, especially if you have concern with quality issues related to compressed air leak detection. Consult with production. We want to make sure that they're aware of what it is that we're doing. If they see us walking around out on the plant floor, around the machines, we want to make sure that they're aware that we're conducting a compressed air leak survey. And we want to make sure that we do the survey during peak operating times. Again, we're not really concerned about plant or ambient background noise, but we want to make sure that we do the leaks under normal operating conditions. And typically that's going to be during those peak operating times. Select the personnel, make sure that they're aware of exactly what it is they're going to be doing. Don't just pull them into a room one morning and say, hey, we need you to go out to find some leaks. Make sure that they're trained, make sure they're qualified, make sure they know how to use their ultraprobe, and then also make sure they have proper PPE. Make sure they're aware of any areas that they're going to go into where there may be heavy equipment being operated in the area, possibly any kind of lockout, tagout areas. In those types of environments, probably be useful to have more than one person go out with that individual, just for another set of eyes, just someone to kind of watch out just from a safety aspect. And then select the equipment. Make sure we've got our ultrasound instrument, make sure it's charged, ready to go, make sure it's operational. We're going to talk about leak tags, make sure that we have hangers for those tags, and then any other type of equipment that we might need, such as a clipboard, a wipe rag, some of those types of equipment that we recommend that you bring out with you. We kind of use those sometimes as shielding techniques. So we talked about how, high frequency sound has a tendency to bounce and reflect off of. Well, you can use that clipboard or you can use that wipe rag as a way to help to block out any competing noise that might be in the area. It just makes it easier to pinpoint exactly where that leak is coming from. So as far as the logistics of the survey, typically we'll recommend that you start in the compressor room. So that's your first area. Then you'll work your way out through the overhead distribution lines, and then finally down to the areas where the compressed air is being used. When you break it up into areas, break it up into zones, it makes it easier just simply for managing the data. And it also, when we generate the reports, it also gives us, we know the areas where we have the greatest opportunities as far as the number of leaks and the total cost for those leaks. So it's an easy, manageable way to look at our data. We want to, you see on the right here, our leak tags. So you can get leak tags from just about anybody. Any of your suppliers, you can probably find leak tags. The leak tags that we offer at UE Systems, they're really a two-part tag. So you've got this main portion up at the top that we can write our information. So we've got the leak number or the tag number, the date. We can write some descriptive information there as far as the location of the leak, the type of gas, the pressure. And then you've got a perforation, and you have a smaller tab down here at the bottom that we can write the same information on. So the reason it's a two-part tag is once we locate that leak and we're ready to tag it, we can write that information on that leak tag. We tag the leak, and then we can tear that bottom piece off, and we bring that back to us that we can use just for reference. So once that leak is repaired, when that technician is going to go out to fix that leak, they're going to see that leak tag portion still hanging there, so they know where the leak is. And then once it's repaired, they're going to remove that tag, and then they're going to bring it back, and then we can document and match up that leak was repaired. So that's the reason for the two-part leak tag. Now, specifically, again, some more specific information about compressed air leak detection. So we talked about how, really it's not just compressed air, but any kind of specialty gas or pressurized gas. But the minimum PSI that's needed for ultrasonic leak detection is 5 PSI. So that's what the spec is rated for on the standard scanning module that comes with every ultraprobe. It's rated to find leaks starting at 5 PSI. You get below that, and there's just not enough turbulence created to produce enough high frequency sound that is detectable with an ultraprobe or an ultrasonic instrument. Now, one of the factors built into the formula, so we've kind of talked about, we're able to quantify these leaks. We talked about the decibel level, but also what's needed is the pressure and then the cost per kilowatt hour of electricity. Those are the three factors that we need in order to be able to quantify or put a dollar amount and a CFM loss to that leak. One thing that's important to note is, where do we want to take that decibel level reading, or at what distance away from that leak do we want to take the decibel level reading? When the research was done for this, going back probably 20 years ago, there's been additional research and studies between then, but the original was done probably 20 years ago. There were known leak sizes created, and then at different pressures. And what was found, as far as the distance away, where we want to note the decibel level reading, that would get us as close to the actual dollar amount and CFM loss for that leak, was approximately 15 inches away from the leak. So once we've identified exactly where that leak is coming from, we just simply back away approximately 15 inches from the end of the rubber focusing probe, and we'll take or note the decibel level reading from that distance. If you take those decibel level readings too close to the leak, it tends to overestimate how much that leak is costing. So in this short little video here, there won't be any sound with this video, but you're going to see that's exactly what we're doing. So you notice here that we're standing back several feet away, and we teach this as the gross to fine method. So you've already heard me talk about the sensitivity adjustment and how that's a way to narrow down the field of view or to block out competing noise. So we can start our survey from several feet away from our equipment, and we're going to scan the area left and right, up and down, and the sound will lead us in the direction of where that leak is coming from. But the whole time that we're adjusting that sensitivity, the whole time that we're scanning, we're going to be adjusting the sensitivity, and we're finally going to be able to pinpoint exactly where the leak is coming from. And then once we've isolated that leak, that's where we're going to back away approximately 15 inches. So that's what you'll see here in the video. You can see that we're just sweeping the area left to right, up and down. Now the scanning module that's on that UltraProbe 15,000, again, it's rated for distances up to 50 feet away, and that's at the maximum sensitivity. So we can potentially hear the sound up to 50 feet away. But you can see as we're moving closer to where that leak is coming from, now we're ready to pinpoint using the rubber focusing probe, and there's the leak. And then if we were going to take that reading, we would just simply back away approximately 15 inches and note the decibel level from that point, or from that distance rather. Now, while you're out doing your initial walkthrough or scan of your area, look for areas of misuse. These are just some typical ones here. You've got optical scanning equipment cleaning, where we've got air constantly blowing on a sensor, air hoses that are frayed or clamped. Air knives are, areas where you can have tremendous savings, and there's other equipment out there that can do the same purpose without having to use compressed air. Conveyor belt cleaning is a common one. Cooling machinery or motors, to some of us, it may sound horrible, but you'd be surprised at how many times I've been out in plants and facilities and seen that. Worn cylinder packing, O-rings, broken diaphragms, bleed off vents. A lot of times too, telltale signs are going to be like the dust collectors, as I call them, where you've got leaks. Your compressed air is going to have moisture. It's going to have oils in it. So over time, those leaks become dust collectors. So those are, again, telltale signs of leaks. Now moving into reporting and documentation. So this is what the app looks like. So again, if you go out into Google Play or the App Store, you'll see, and if you search UE Systems, you'll see the Leak Survey app. So it'll start you out here at Begin Leak Survey. And then once you hit Begin Leak Survey, it's going to start you out at record number 1 or leak number 1. So using our UltraProbe in conjunction with this app, we locate a leak. We enter the decibel level reading there from, again, approximately 15 inches from the leak. We can type in a detailed description, the type of gas. We have it set up for not only compressed air, but also argon, helium, hydrogen, and other. So, for example, if you're using nitrogen, you would just rename other, call it nitrogen, and now you've got it set up for a different type of gas. We'll enter the pressure, ideally the pressure at the leak. If the air may start out at, say, 110 psi, but where it's actually being used, it may be regulated down to 75 psi. So we would want to note the pressure at the leak, and then we can take a photo of that leak. And we can do that for ever how many leaks we want to find. And then we have the three little dots up in the top right-hand corner. You'll just simply touch those, and it'll come up Generate Report. So when you hit Generate Report here, you can name that report, and then once you name it and hit OK, that report will then be attached to an email that you can email to yourself or email to a colleague, and it's going to look like this. So this was actually a survey that I did at a facility close to me during a training class. Now, we had found a total of 13 air leaks, and you can see they were all compressed air. They were all 75 psi. Here's the decibel level reading from those leaks. But if you look at the total here, so these 13 leaks, the cost per kilowatt hour at this plant was 7 cents a kilowatt hour. These 13 leaks were costing this facility almost $4,400 per year. So it is an annual basis, but we can change that. You have a cost tab down at the bottom, and that's where you would enter your cost per kilowatt hour of electricity. But you can also change your hours of operation. So if you know your plant is going to be shut down, or if you know the air is going to be turned off a certain number of days, then you would just simply change that. But the default is 24/7. But it gives you the individual cost, the individual CFM loss, and then these last four columns here, that's your energy and your greenhouse gas emissions information. So we got that information, at least here in the States, we got that information from the Department of Energy on a state-by-state basis. So you would just simply specify where your state is, and that'll give you the greenhouse gas emissions for your state for how the power is produced, whether it tends to be more, fossil fuel, or if it's more cleaner type energy like hydro or even nuclear. Now, you also have a pictures tab. So that'll give you the picture for the leak as well as the cost, and then any kind of description that you put in there. So this really becomes a work order system for your air leaks. And again, it's an easy way. I'll back up one page here, one slide, and you'll see that you have a repaired yes or no tab. So when those leaks are repaired, we can just simply change these no's to yeses, and that will in turn update the spreadsheet for you. So it's a way to track your progress both on the number of leaks repaired as well as the savings that's been identified, and then the reduction in greenhouse gas emissions. So you can track your carbon footprint reduction. So just wrapping up, I would recommend start small. Pick an area, pick a machine, pick a line, pick an area where you have the greatest opportunity. Take your, locate your leaks. Make sure you repair those leaks. It's one thing to find them, but to realize the savings, you've got to repair those leaks. I was in a plant just a couple of months ago, and we found a few leaks that there were multiple tags hanging. There were tags going back as far as 3 years. So the leak had just been constantly found and found and found again. But yet again, we've got to repair those leaks to realize the savings. Take your before and after readings on your compressor monitoring system. So if you have a way to monitor, let's say the amp drawage on your compressors before the leak survey and then after the leaks have been repaired, I guarantee you'll see a decrease in amp usage after those leaks have been repaired, just simply because the compressor is not working as hard. Document your findings. We try to make it as easy as possible for you. People that are currently using that leak survey app absolutely love it, just because it is simple and easy. Right from your phone or your tablet, you can generate that report. It totally bypasses having to store the data on the UltraProbe and then download the data into the software to generate the report. We can do it right from your phone or your tablet. Then you want to make sure that you partner with a reputable compressor company or a reputable compressor or compressed air consultant for other recommendations. But I'm telling you, if you start with a leak detection survey and then you repair those leaks, you'll see immediate improvements in both your efficiency, and a lot of times you can totally bypass having to get in additional compressors to keep up with the demand. So with that, we'll open it up for questions if we have time. And if you want some additional information, yeah, we have a written procedure for compressed air leak detection. So I'll be glad to share that and make that available to you. Maureen, I'm sure, will mention that this is being recorded. So if you have colleagues or other people that you'd like to forward this on to, you'll get a link to the recording, and feel free to share that out as well.
Okay, Adrian.
Maureen, are you there?
Okay, I think I lost my. Yeah, can you hear me now?
Yeah, I got you.
Okay.
Yep.
Oh my goodness, my silly little headphones again. Okay, so one question or kind of topic that quite a few people were typing in, asking for some clarification and had some interest around, was on vacuum leaks. So maybe you could do just a quick little once over on how that works. I think that would knock out quite a few of these inquiries that we had.
Yeah, I thought about vacuum leaks, but I failed to mention it, so I'm glad the question came through. So yes, I mean, with vacuum leaks, it still creates turbulence, but you have to think that, most of that noise is being sucked in versus blown out to atmosphere. So certainly we can detect vacuum leaks using ultrasound. Will it detect every vacuum leak? No, but if you have, vacuum systems, a lot of times it's a great place to start because ultrasound is really good at finding your larger or your more gross type vacuum leaks. So typically, once those vacuum leaks are repaired, you've gotten back enough, demand on that system to where it can be effective. Now, unlike pressure leaks to atmosphere, where we have a specific a spec to where we can find those leaks, there is no spec for vacuum leak detection. So again, will it work every single time? No, but again, it's a great place to start. There is an attachment that you can get for an UltraProbe 2000, a 9, a 10, and a 15. It's called the close focus module. So it's a module or an attachment that's specifically designed for low level leak detection and vacuum leak detection, and it's just a more directional version of the scanning module. So if you look down inside of it, it's a funnel shaped or a parabolic. So it's designed to kind of funnel that low level noise down into the center. So it makes it very directional and better suited for vacuum leak detection and lower level pressure leak detection. But that's really about all I can say about vacuum leaks. But they do create turbulence, and it is something that's detectable using airborne ultrasound.
All right, awesome. Hopefully that helped folks. And of course, feel free to get in touch with us offline, and we can dive in deeper. So another question, we don't normally kind of get into kind of cost, but let's just say if someone was, just to give people a feel for it, if they were wanting to get started with ultrasound, leak detection is kind of the application they want to dive in with. And so, for instance, like the 3000 being a great instrument for that, kind of what's a starting cost that you could kind of let folks know what they'd be expecting so they could get started?
Yeah, that's a good question. It's a valid question. So like the UltraProbe 3000, we make a kit specific for leak detection. It's called the UltraProbe 3000 SL kit, which comes with the scanning module. It comes with the long range module. So if you do have those overhead airlines, and then it also comes with 200 leak tags. It's around $4,200. So you pair that with the Leak Survey app, which is free. That's your reporting, and that's that's what you would need for your leak survey. And it'd be super easy. It's basically pull the trigger, and you can put that in the hands of anyone, and they can go out and find a leak with some, basic training and kind of tips. But yeah, so the UltraProbe 3000 SL is around $4,200, and again, that's your leak tags, that's your instrument, and then you pair that with the app.
Perfect. Okay, good information to know. I had a few people kind of asking for some comparisons, so that's great. Okay, and then one last one that I think you did kind of cover it, but it's always good to kind of end on this note. But someone was saying you often hear that people go out, they find the leaks, and now they've got these pretty decorative leak tags hanging throughout their facility. Kind of just maybe one more sort of advice for how you can kind of keep those from collecting dust and actually getting fixed and moving forward.
Yeah, that's a good question. I'll tell you one of the best leak detection and repair programs that I've seen, and they actually did a webinar for us several years ago. They put together a leak repair, it's a leak detection and repair cart. So they kept their UltraProbe on it, they kept their leak tags, but also on that cart, they kept anything that they could fix the leak on the spot, they kept on that cart. So wrenches, fittings, tubing, whatever they could use to fix it on the spot if they could, it was all on that cart. So instead of having to tag that leak and then put in a work order and, come back later to fix it, they would just fix it right on the spot. So that's one way. But another way is putting a dollar amount to it. So if you've got a leak out there and you tag that leak and it's a $700 a year leak, do we really want that tag just hanging there for another 2-3 years? No. So part of that too kind of comes from creating the awareness and buy-in for how much those compressed air leaks are costing. And if we start that kind of initiative, then again, you'll have some people in upper management that will want those leaks fixed once they realize how much those leaks are costing.
Yeah, document procedures and celebrate those wins, right? So that's great.
Right.
Awesome. Okay, so there were a lot of questions and a ton that were flooding in kind of here towards the end, but in the interest of time and letting everybody get on with the rest of their day, we will follow up with you all offline. So if we didn't get to your question, just sit tight and you'll hear from us directly, and we'll get you all squared away. But again, great information today. Just to remind, we did record this. I'll have it up on our YouTube page. So just go to YouTube and then type in UE Systems, and you'll find all of our videos on there, including this one. So definitely check that out. Just another reminder, we do have a ton of online training courses, one of which is specific to compressed air leak detection. So a great resource if you want to dive in a little bit deeper, or if you really do want to get started on this, it's a great resource to have. Once you have a login for it, you've got it for up to a year. So you can always be going back and checking it out. And we do have a sale going on all of our online classes right now. So $100 off each of them, which makes the compressed air class only $295. So that's a ton of content, a ton of information. And it's not just the way, if you haven't seen any of our online classes, it's not like you're just watching kind of someone reading a PowerPoint presentation. They're actually interactive modules where you're watching videos, you're interacting, you're answering questions, you're very engaged, and they're pretty cool. So just something to think about if you would like to learn more or dive into any of our other applications, as we've got classes on all of them. And then with that, I'll leave our contact info up here. So definitely reach out to us, call the office, email me, email our info, check out the website, and we will get whatever help it is that you're looking for. Or if you just want to reach out and talk, hear someone else's voice, we're happy to do that too. But anyway, so thanks again, everybody, for joining us. Adrian, awesome presentation as always. And we will let you all go. Have a great rest of your day, great rest of your week, and we'll catch you guys later.